Welcome back, everybody. This is our eighth session in JEE mains previous year questions for chapter Ray Optics and Optical Instrument of class 12th. Before this video, we have made 7 videos in this series, and all of those videos are available on our YouTube channel's playlist section. And if you find these videos helpful, useful, then do press the like button, share them, and subscribe to our channel. We have also started similar series for NEET aspirants also. So if some of your friends are preparing for NEET, then you can guide them through those videos. And if you like to donate us, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, let's start today's video. In the previous one, I think we covered up to 50 or something. Yes, this was the one of the last. That is 58. And today we will start with 59. So here we have a thin convex lens made of a crown glass. Refractive index is 3 by 2, has a focal length f when it is measured in two different liquids having refractive indexes 4 by 3 and 5 by 3. It has focal length f1 and f2 respectively. The correct relation between the focal lengths will be. So from the lens maker's formula, we know that 1 by f will be equal to refractive index of the lens divided by the reflective index of the medium minus 1, and here we have equals to, into 1 by r1 minus 1 by r2. Now, as we see here, refractive index of the lens is 3 by 2, and that is 1.5. Now, refractive index of the first liquid, we can say, or medium, that will be 4 by 3, that is 1.33. And for second, it is 3 by 5, so it is basically 1.67. 5 by 3, 1.67. So we can see that mu1 is less than mu l and mu l is less than mu2. So in this situation, this lens is originally a convex lens. So in this situation, it will behave like a convex lens with positive focal length. And in this situation, it will behave like a concave focal lens with negative focal length. So if we say this is, now we have to find out. So this will be f1 and this will be f2. So f1 is positive here and f2 is negative. So we can say f1 will be greater than f2. And also we have to compare it with f, and f will be positive, but value of f will be the highest. So f should be greater than, I think, oh sorry, here from this we can write that f is inversely proportional to refractive index of the lens. So f will be smaller than f1. So we can say f1 will be the greatest, then we will have f, and then we will have f2 as negative. So that is option B here. So let's move ahead. The refractive index of the material of a concave lens is mu. It is immersed in a medium of refractive index mu1. A parallel beam of light is incident on the lens. The path of the emergent ray when mu1 is greater than mu. So here refractive index of the environment is greater than the refractive index of the lens. Now normally what concave lens do? If we have a concave lens like this, and normally it will converge the light. It will normally converge the light, and this will only happens when, suppose this is mu and this is mu1. So it will only happen when mu is greater than mu1. Now if we reverse the refractive indexes, then if mu1 becomes greater than mu, then this concave lens will behave like a convex lens. So basically we can assume that we have a convex lens here. So what will convex lens do to a parallel beam of light? It will focus on the other side. So that is shown in option A. So option A will be the right answer here. Now let's move ahead. An object is located in a fixed position in front of a screen. Sharp image is obtained on the screen for the two positions of thin lens separated by 10 centimeter. The sizes of two images in situation are ratio 3 ratio 3. What is the distance between the screen and the object? Now first we make a correction here, that it is 3 ratio 2, not 3 ratio 3. So we can say sizes of the images are in the ratio. So basically it means we have magnifications are in ratio. So m1 divided by m2 is equal to 3 by 2. And here we have that, as mentioned, that object and the screen is fixed. So suppose this is our, this plane represents our object and this represents our screen. So initially we have system like this. Our lens is here. Now this is u and this is v. Now we change the position of the lens so that this difference is 10 centimeter. Now this becomes u and this becomes v, because in fixed object and screen scenario, the position of the object and the image is interchanged with each other. So here in the first one we will have m1 is equal to v by u, and in the second we will have m2 is equal to u by v. And if we divide both of these, we will get m1 by m2 is equal to v square by u square, and that is equal to 3 by 2. So, and also we know that this distance is 10 centimeter, and we know initially it is v. So this distance is v and this distance is u. So this remaining distance, that is 10 centimeter. So we can write v minus u is equal to 10 centimeter, or v minus u is 10. So from this v is equal to 10 plus u. So here if I substitute it here, so 10 plus u divided by u whole square is equal to 3 by 2. And from this I can write that 100 plus u square plus 20 of u divided by u square is equal to 3 by 2. Now cross multiply. 200 plus 2u square plus 40u is equal to 3u square. And from this we will get that u square minus of 40u plus of 200, oh sorry, negative of 200 is equal to 0. And if we solve this, we will get value of u is equal to 44.5. Now u is 44.5, then v will be 54.5. And now let us check. We have to find out distance between screen and object. So distance between screen and object will be u plus v. So u plus v, that will be 54.5 plus 44.5. This will give us 99. That is option D here. Let us move ahead. Diameter of a plano-convex lens is 6 centimeter and thickness at the center is 3 millimeter. Speed of the light in the material of the lens is 2 into 10 raised power 8 meter per second. What is the focal length of the lens? So from the speed of light we can find out the refractive index. Refractive index mu will be equal to c by v. That is 3 into 10 raised power 8 divided by 2 into 10 raised power 8 will give us 1.5. And now we have the diameter and thickness at the center. So we can say here this is a plano convex lens, so it will look like something this. Suppose this is our lens, this is the planar side and this is the convex side. Now this distance, that diameter is 6 centimeter, and the thickness at the center is 3 mm. Now keep one thing in the mind, that this is not a hemisphere. Let me draw a proper 3D diagram so that it is better understandable. let me change this to sphere. So suppose this is our hemisphere, and if I rotate this, then what do I mean by this diagram? Then this is the space where we cut it. Here we have only this small cross section of this hemisphere. So this is equal to 6 centimeter, and this is the thickness of the lens. So basically this will not be the radius. This will not be the radius. This is basically the thickness of the lens. So, and that is given to be here 3 mm. So what we can do here, suppose this is the center. So this distance is equal to the radius, and suppose this point is O, this is A, this is B, this is C, and this point is D. So if I make it right angle triangle here, so in this right angle triangle I can write that OA square is equal to AD square, this distance, plus OD square. Now OA is equal to the radius, so radius square is equal to AD. AD is half of the diameter, means 3 square, plus OD will be equal to the radius minus thickness, and thickness is 0.3 mm, and that will be 0.3 centimeter. So when we solve this whole equation, we will get radius approximately equals to 15 centimeter. Now we have the radius of curvature. So what we can use the lens maker's formula, that 1 by f will be equal to mu minus 1 into 1 by r1 minus 1 by r2. Now for this side, radius of curvature will be positive, and for the planar side here, this is the planar side, this planar side, it will be infinite. So using the lens maker's formula and radius 15 centimeter, I can write that 1.5 minus 1 into 1 by 15 minus 1 by infinite. And when we solve this, we will get focal length equal to 30 centimeter. That is option C here. So let us move ahead. The image of an illuminated square is obtained on the screen with the help of a converging lens. The distance of the square from the lens is 40 centimeter. The area of the image is 9 times that of the square. The focal length of the lens is. So we know that aerial magnification is equal to the square of lateral magnification. So basically here area magnification is 9 times, so we can say m square is equal to 9, and from this m becomes equals to 3. Now if m is 3 and we are discussing here regarding length, so m is equal to v by u. So from this we will get 3 is equal to v by u, or v is equal to 3 by 3, and this magnification can be either positive or negative, so we have to keep in this mind. So to help to find out that whether it is negative or positive, so as mentioned here, that image is obtained on screen. So if it is obtained on screen, it is a real image, so magnification will be negative. So this will be negative and this will be negative. Now from this, let us here, the distance of the square from the lens is 40 centimeter, means u is going to be minus 40, so v will be equal to 120. Now we can find out the we can use the lens formula, that 1 by f will be equal to 1 by v minus 1 by u. So 1 by 20 minus of minus 40, so this will give us 40 plus 40, multiply 3, divide 3, and this will be 4 by 120 or 1 by 30. So focal length is 30 centimeter. That is option D here. Let us move ahead. So here we have a object at 2.4 meter in front of a lens forms a sharp image on the film 12 centimeter behind the lens. So it will be a real image. Glass plate of 1 centimeter thickness of refractive index 1.5 is interposed between the lens and the film with the plane face parallel to the film. At what distance from the lens image should be shifted to be in sharp focus with the film? Now, first of all, let us discuss that what happens when we add some film between the lens uh, and the screen, or some glass plate. So suppose this is our lens, and this is the principal axis here, and this is the some glass plate of some thickness which we have added. Now, initially, suppose, okay, so yes. So suppose initially this was a parallel beam of light was coming, and it was getting focused here. Now this is before this glass plate is added. Now what happens due to addition of this glass plate? That refraction will happen. So due to refraction, this light will bend towards the normal. So now this light will go like this. Let me take different color. So let me use this one. So this light will bend like this. Now again this light will bend like this, and so light will be focused at slightly larger value of V. So this will be the basically shift between the U and V, and this shift will be caused due to the this glass plate, and that shift is equal to that we can say delta of D, or the shift is equal to thickness of the slab into 1 minus 1 by U, and that will be equal to, here thickness is 1 centimeter, and it will be 1 minus 1 by 1.5, that is mu, and this is equal to 1 by 3 centimeter. So this difference is 1 by 3 centimeter here now. So initially object was at this, and so initially our V initial was 12 centimeter as already mentioned in the statement. So initially image was forming at 12 centimeter, and now we can say V final is 12 plus 1 by 3 centimeter. Now what we want, that we don't want to shift the film here. Initially we had a film here or screen here. We don't want to shift this screen. We want image to be formed here again even after placing this glass slab. So we know that this shift due to glass slab is constant. So if somehow we adjust our V to 12 minus 1 by 3, that is, if somehow we adjust our value of V to this, then with slab, what will happen? With slab, this will become 12 minus 1 by 3, plus due to slab, we have 1 by 3 extra. So these 1 by 3 get cancelled, and we will get our final image at 12 centimeter where we have the screen. So our value of the new value of V is equal to, that will be 36 minus 1 means 35 by 3. So to change value of V, what we have to change? We have to change the value of U. So we have new value of V. Using the lens formula, we can find out the value of V. So from the lens formula, we have 1 by F is equal to 1 by V minus 1 by U. And focal length, we don't know. So focal length also has to be calculated, and focal length can be calculating using initial values. So let us first calculate the focal length. So using initial value, we will have 1 by F is equal to 1 by V 1 by 12 minus of 2.4 meter it is, so it will be negative 240. And from this focal length, or 1 by f, comes out to be 21 by 3 240. Now we will use this again lens formula for the newer value of v, and we know newer value of v is 35 by 3. So now 21 by 240 will be equal to 35 by 3 minus 1 by u, and from this the value of u will comes out to be 5.6 negative meters. So this will be the value of u, on which if we place the object, its image will be formed at 12 minus 1 by 3 without slab, and with slab it will become 12 centimeter, which is the place where we have the screen. So, and if we match, then that is option D. So option D is the right answer for this question. Now let us move ahead. When a monochromatic red light is used instead of blue light on a convex lens, its focal length will. So for that we know that refractive index is inversely proportional to lambda, and we know that lambda of red is greater than lambda of blue. And if lambda is greater, it means refractive index of blue is greater than refractive index of red. And from the lens maker's formula, 1 by f is equal to mu minus 1 by r1 minus 1 by r2. So from this we know that focal length is inversely proportional to mu. So if some color has a higher refractive index, its focal length will be less, and blue has the higher refractive index. So we can say focal length of the blue will be smaller than the focal length of the red color. So monochromatic red light is used of instead of blue. So we have replaced red with blue. So focal length will increase, and that is option A. Now let us move ahead. In an optics experiment with the position of the object fixed, student varies the position of the convex lens, and for each position screen is adjusted to get a clear image of the object. Graph between object distance u and the image distance from the lens is plotted using the same scale for the two axes. A straight line passing through the origin and making angle 45 degree with x-axis meets the experiment curve at P. The coordinates of the P will be. So as per statement, we have to plot a graph between V and U for the same lens. And if lens is same, means focal length is constant here. So from the lens formula, we can write that 1 by V minus 1 by U is equal to 1 by F. And from this, we can form a relation that V is equal to U times F by F plus U. Now, let us try to plot this graph. So for that, so if I do that, suppose these are our x and y axis, and here I have u, and here I have v. So let us first discuss two cases. First one is that if u is infinite, means object is infinite, then we know that v is equal to f. So for that, let us mark a line here. Suppose this represents f here on the u, and this represents f here on the v. And reverse is also true, that if u is f, then v will be equal to infinite. So starting with here, when v is infinite, then u is almost f, and when u is infinite, V is almost F. And we have another point also, that for a lens, when U is equal to 2F, then V is also equals to 2F. So for that, we have to add another line of 2F. Suppose this is 2F and this is also 2F. So this curve will correspond to like this. Curve will go like this. Now, as per the question, a straight line passing through the origin and making angle 45 degree with the x-axis meet the experiment curve at P. So we have to draw a straight line here, and that straight line will be passing through the origin like this, and it will be meeting our curve, this curve which we have drawn here like this, at point P, and this will be the point P. Now from the diagram you can easily see this is point 2F, but we can also solve it mathematically, because here slope is 45 degree. So slope is 45, so we can say slope will be equal to 1. So equation will be y is equal to mx plus c. Now y is v here, slope is 1, x is u, and as it is passing through the origin, so c will be 0. So for this line we will have v is equal to u, and there is only one point on this curve for which we have v is equal to u, that is 2f and 2f. So answer to this question will be option D, 2f and 2f. And with this we end this video here. Hopefully whatever we have covered is helpful to you and useful also. Again, if you find these videos useful, then do press the like button, share them, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.